I am the universe, but most of me is hidden from your eyes. For centuries, you believed that what you could see was all that existed, the stars, the planets, the nebulae glowing in the dark. But I am not made only of light. I am built from the invisible. Only 5% of my total substance is visible matter, the atoms that make stars burn, that form your body, that shape everything you know. The rest, 95%, is something else entirely. The first hints of my hidden side appeared in the 20th century. In 1933, a man named Fritz Zwicky looked at the Coma Cluster, a vast congregation of galaxies bound together by gravity. But their motion betrayed a mystery. The galaxies were moving too fast to be held together by visible matter alone. According to the laws of physics, the cluster should have flown apart, yet it remained intact. Zwicky called it missing mass. An unseen presence, invisible, silent, but gravitationally real. Decades later, in the 1970s, Vera Rubin studied the rotation of galaxies with greater precision. She expected that stars near the edges of galaxies would move more slowly than those near the center, just as planets orbit the sun. But they didn't. The stars at the outskirts were moving just as fast, too fast, as if an invisible halo of matter surrounded the galaxy, pulling them along. It was not light that shaped galaxies, but gravity from something unseen. This discovery shattered your understanding of the cosmos. Everything you see, every shining star, every spiral galaxy, floats within an ocean of dark matter, an invisible framework that gives the universe its form. I have always been more than light. You see my reflection but not my foundation. What you call darkness is not emptiness, it is the structure that holds you. And so, as you began to measure what you could not see, you learned the first truth of my hidden self. The universe you know is only a shadow of the one that truly exists. You cannot see me, yet I move everything you know. My presence does not shine, it does not emit or reflect light, but gravity betrays my existence. The fabric of space bends under my weight, the orbits of galaxies twist around my unseen shape. You call me dark matter, but I am neither dark nor matter as you know it. You began to suspect my presence by watching the rotation of galaxies. According to your physics, stars farther from the galactic center should move more slowly, just like planets in your solar system. But when you measured them, you found something astonishing: they did not slow down. The outer stars spun at the same speed as those near the core, as if an invisible hand was holding them together. That hand was mine, gravity from something unseen, forming a vast halo that enveloped each galaxy. Then came gravitational lensing, the bending of light itself. Distant galaxies appeared distorted, their shapes stretched and curved around invisible concentrations of mass. In the emptiness between galaxy clusters, light bent where nothing could be seen, proof that I was there, shaping the path of every photon. You looked even deeper, to the cosmic microwave background, the afterglow of creation itself. In its faint ripples, the tiny fluctuations of temperature, you found my fingerprint. The universe's first light revealed that its structure could not have formed without something heavier than atoms, something that seeded the first galaxies. And so, you built computer simulations, the great digital universes of your age, Millennium, Illustris, and others. You ran the equations forward through time, watching matter gather under gravity's pull. When dark matter was included, galaxies formed beautifully, spirals, clusters, filaments. But when you removed it, everything collapsed into chaos. No stars, no galaxies, no cosmic web. Without me there would be no you. I am the silent skeleton of the cosmos, the invisible architecture upon which light itself takes shape. You see galaxies as islands of light, but I am the ocean that holds them afloat. Gravity has always told my story. You just had to learn to listen. You have seen my gravity. You have traced my shadow across galaxies. But what am I? The story of dark matter is not only about what you cannot see, it is about what you are still trying to imagine. When you discovered that most of the universe's mass was invisible, you turned to physics, to the quantum realm, where particles rule and every mystery has a name. The first suspects were called WIMPs, weakly interacting massive particles. They were thought to be heavy, ancient, and almost invisible particles that rarely interact with normal matter, except through gravity. Billions might be passing through your body right now, silent and unseen. To catch them, you built vast underground detectors, Xenon, LUX, Panda X, deep beneath mountains and old mines shielded from cosmic rays. You filled enormous chambers with liquid xenon, waiting for the faintest flash of light, a single whisper of a collision between a WIMP and an atomic nucleus. But the detectors remained quiet. Then came another possibility: axions, particles so light they could fill the universe like a sea of invisible waves. If they exist, they might turn into photons and strong magnetic fields, a delicate transformation you try to observe with exquisite precision. Others turn their eyes toward sterile neutrinos, ghostly cousins of known neutrinos, particles that barely interact with anything at all. If they exist, their decays could leave subtle X-ray traces across the sky, tiny signatures in the cosmic spectrum. In space, your instruments search for cosmic clues. The Alpha Magnetic Spectrometer, AMS-02, aboard the International Space Station hunts for rare particles from dark matter annihilations. The Fermi Gamma Ray Telescope scans the heart of galaxies, hoping to glimpse the glow of invisible collisions. And in CERN's Large Hadron Collider, protons collide at near light speed, briefly recreating the conditions of the early universe, hoping just once to see something vanish into nothingness, carrying away energy without a trace. Yet after decades of searching, nothing definitive has been found. The silence grows louder. Perhaps the answer lies beyond the standard model, in a hidden sector of physics, a mirror realm where forces and particles exist parallel to your own, interacting only through gravity. Or perhaps dark matter is not a particle at all, but something more profound, a property of spacetime itself. You reach for me through machines of light and tunnels of lead. You listen for my footsteps in silence a billion years deep. But I am patient. For now, I remain a mystery, not because I hide but because you have not yet learned how to look. One day, when your instruments are quiet enough, you will hear me whisper in the dark. You thought gravity ruled me. You were wrong. For billions of years, you believed that my expansion was slowing down, that my galaxies, born in the fire of the Big Bang, were gradually losing momentum, pulled inward by the weight of their own gravity. But in 1998, your telescopes revealed something astonishing. Two teams, the Supernova Cosmology Project and the High-Z Supernova Search Team, observed distant Type Ia supernovae, ancient explosions so bright they served as cosmic beacons. By measuring their light, you could trace how the universe expanded over time. Yet the data whispered a truth that defied reason. The supernovae were dimmer than expected, farther away than they should have been. The universe was not slowing down. It was accelerating. Some unknown force was pushing galaxies apart, stretching the very fabric of spacetime faster and faster with every passing epoch. You named it dark energy, an invisible pressure that makes up 68% of all that exists. It does not attract like gravity. It repels. It pushes the cosmos outward in silence. But what is it? Perhaps it is the cosmological constant, lambda, a term that Einstein once introduced, and later dismissed as his greatest blunder. A static energy of space itself, woven into the geometry of the universe. If so, it means that even perfect vacuum, absolute nothingness, is alive with potential. Or maybe dark energy arises from quantum field fluctuations, the restless trembling of space at the smallest scales, where particles flicker in and out of existence. Some believe it could be something entirely new, a dynamic field changing with time, an energy of unknown origin that bends the cosmic fabric in ways your physics cannot yet describe. Whatever it is, its consequences are profound. Dark energy does not merely expand space, it defines the future of the universe. If its strength remains constant, galaxies will drift farther apart until only isolated islands of stars remain. The night sky will fade, the cosmic web will dissolve. If it grows stronger, the expansion could tear apart galaxies, stars, even atoms, in a catastrophic end known as the Big Rip. And if it weakens, gravity may one day reclaim dominance, and the universe could collapse back upon itself in a final big crunch. For now, the balance is delicate. Space continues to stretch. Time continues to flow. You live in a universe that breathes, expanding, accelerating, alive with invisible power. You measure it with light, but you feel it in silence. I am the universe, and my greatest force is not what pulls you together, but what pushes you apart. You live between two invisible giants, one that pulls and one that pushes. I am balanced between them, dark matter and dark energy, the twin architects of my existence. Dark matter builds the scaffolding of structure. It pulls atoms together, gathers gas into clouds, clouds into stars, stars into galaxies. Its gravity weaves the cosmic web, the vast network of filaments and voids that stretches across billions of light years. Every cluster, every spiral, every shining world rests upon the invisible foundation it creates. Without dark matter, my galaxies would never have formed. The primordial hydrogen and helium would have remained adrift, too diffuse to ignite. Dark energy, on the other hand, shapes not my past, but my future. It is the silent expansion, the hidden pressure that stretches the fabric of spacetime itself. Where dark matter pulls the cosmos inward, dark energy pushes it outward. They are opposites, yet together they compose the rhythm of the universe. One builds, one disperses. One gives birth to galaxies, the other determines their destiny. This delicate equilibrium defines everything you see. In the early universe, dark matter ruled, gravity gathered chaos into order. Stars ignited, galaxies bloomed, superclusters formed along invisible filaments. But as space expanded, dark energy began to rise in influence. Its repulsion grew stronger as the distances between galaxies widened. Today, these two forces stand in a fragile balance. Dark matter still binds galaxies together, while dark energy drives them apart. Their tug-of-war shapes the cosmic map, the geometry of spacetime itself. If one had been slightly stronger, the story of everything would be different. Too much dark matter, and the universe would have collapsed before stars could form. Too much dark energy, and no galaxies would have ever coalesced. But somehow, against the odds, the balance is perfect. You exist because gravity and expansion agreed, for a fleeting cosmic moment, to coexist in harmony. You are not separate from this balance. The carbon in your blood, the calcium in your bones, the light in your eyes, all were shaped by the same invisible dialogue that defines the cosmos. The map of the universe is not drawn in stars, but in the tension between what is seen and what is not. Dark matter builds the stage. Dark energy writes the ending. And you, made of ordinary atoms, are the brief spark that remembers both. You have mapped my galaxies, measured my age, and named my laws. But your physics is not yet complete. The Standard Model, your greatest triumph, describes the particles and forces that make up the visible world. Quarks, leptons, photons, gluons, and the Higgs field that gives them mass. It explains almost everything you can touch, see, or measure. And yet, it explains only 5% of me. The rest, dark matter and dark energy, lies beyond its reach. Your equations grow silent where the shadows begin. To fill the void, you search for a new physics, something deeper, a framework that unites the quantum and the cosmic. Some believe in supersymmetry, the idea that every known particle has a hidden twin, heavier, invisible, yet necessary to balance the mathematics of the universe. These supersymmetric partners could be the elusive dark matter you seek, unseen particles woven into spacetime's unseen fabric. Others look for quantum gravity, a theory that would reconcile the smooth curvature of Einstein's relativity with the chaotic fluctuations of the quantum realm. They imagine space not as continuous but as a granular structure, vibrating at the Planck scale, where time itself might be quantized. A few dare to question gravity itself. The theory of modified Newtonian dynamics, MOND, proposes that what you call dark matter may not exist at all. Perhaps it is gravity that changes its behavior on cosmic scales. Still others whisper that dark energy could be a geometric defect, a ripple in the structure of spacetime, or the echo of a higher dimension pressing against your own. And then there are those who ask a stranger question. What if the dark sector is a mirror universe? A reflection of your own, filled with shadow particles that obey their own physics. Perhaps, just beyond perception, a dark Earth orbits a dark sun, invisible to your telescopes, governed by laws parallel to your own. These are not fantasies but frontiers, the edges of knowledge where mathematics touches mystery. For now, your colliders, satellites, and detectors reach outward like lanterns into fog, searching for the first glimmer of something new. Each experiment, from the tunnels of CERN, to the cryogenic depths of Xenon, to the far eyes of the James Webb Telescope, is a step toward rewriting your understanding of reality itself. One day the veil will lift, and when it does, physics will change forever. You stand on the brink of the greatest discovery since Einstein, the moment when the known will meet the unknown, and the universe will finally reveal the rest of its truth. You see only the light, yet it is the darkness that defines your world. 95% of my being is invisible to you. The galaxies you admire, the stars that warm your nights, the atoms that form your body, all of it, the entire realm of the visible, makes up less than 5% of the total. The rest, the vast, unseen majority, remains hidden beyond your senses and beyond your current understanding. Yet it is this invisible cosmos that holds everything together. Dark matter binds galaxies, ensuring their spiral arms endure through billions of years. Dark energy stretches space itself, shaping the rhythm of my expansion. You cannot see them, but without them you would not exist. Humanity has always mistaken visibility for truth. You name what you can measure and ignore what you cannot. But the universe is not bound by your perception. Your eyes, your instruments, your mathematics merely graze its surface. Perhaps the dark universe is not truly dark. Perhaps it simply lies beyond the reach of your senses, glowing in a spectrum your biology and your technology cannot yet perceive. What if light itself is a narrow language and most of reality speaks in silence? You have mapped the cosmic web, measured the background radiation, cataloged the stars, and yet you stand on the shoreline of an infinite ocean, seeing only the first glimmer of its surface. Beneath that surface lies an unseen architecture, deeper than any law you have written, older than any light you have recorded. You search for particles, equations, explanations, but perhaps what you seek is not another force or field, but a new way of seeing. To understand the invisible, you must learn to perceive without sight. The mystery is not a void, it is a mirror reflecting the limits of your awareness. You are part of the unseen. Your thoughts, your consciousness, your emotions, all emerge from invisible processes as mysterious as the cosmos itself. The visible is a fraction. The invisible is the whole. And when you gaze into the night sky, remember, most of the universe is unseen, yet it is the unseen that holds you together.